Hello everyone and welcome to today's challenge video for this week. Technically this is going to be a two-part one, so I'm going to do one this week and I'm going to do another solution for it next week, since this is a very complicated way to solve it. This week we're going to go over the easy solution, but it's also the most time-consuming solution, and it's not the best when it comes to big O notation. So what is the challenge? Well, the challenge is the inversion count for an array indicates how far the array is from being sorted. If the array is already sorted, then the inversion count is 0. If the array is sorted in reverse order, then the inversion count is the maximum possible value. Given an array, A, find its inversion count. Since this number could be quite large, take a modulo 10 to the 9th plus 7 to it. So our first solution isn't actually going to take that 10 to the 9 plus 7 modulo to it. We're just going to toss that out of the window. But I don't necessarily know if it's actually going to solve it. As you can see, I have done the sample test, but I did not actually submit it to see if my solution works. But there are two different solutions that we could do here, and one of them is going to be a lot simpler than the other one. However, it could fail the total execution time limit of 3 seconds. So basically, what we need to do is, I've already started drawing. We need to, one, have a start to the array. What I mean by this is that, we have an array. Let's say our array is 3, 1, 2. We need to have a start. We need to know what our starting point is. Our starting point is usually always location 0. So this is going to be location 0. And what we're going to do is have a second start of 1 plus 1. Or really the location at location 1, so L1, that says 4 now, of location 1 plus 1. So since we have 0 is location 1, so location 1 equals 0, I want location 2 to equal 1. And I always want location 1 to be 1 less than location 2. And basically what I'm going to say is I'm going to compare the two entries that we have here, so 3, compare L1 to L2, and if L1 is greater, meaning that it should be moved further down in the array, add 1 to inversion. Increment L2 until end of the array. So technically, if I take this and I want to do this, and then step 5, increment L1 until end array. So technically, if I test this out, what my code is going to do is I have 3, 1, 2, and I have my count. And what I'm doing is my L1 and L2. So I'm just going to create a small little grid here. So L1 is 3, L2 is 1. And my count is going to be 0 currently. So this is what I'm starting off with. So this is my start. I then have a compare. And this is either going to be true or false, that L1 is greater than L2 of L1 greater than L2 comparison. So if L1 is greater than L2, then I'm going to increment count. So this is true. So when I go through and fill this in, count is going to be 1. L1 doesn't move until L2 is going through the array. So I stay with 3. This moves to 2. And this is also true. So then this turns to 2. 2 goes back to 1. This gets incremented, then this gets incremented. So therefore, I am now at 1 and 2. and this is false, and then I can't really do anything, so my inversion count for this is 2. I can't continue on because L1 always has to be less than L2. L2 can't go any further, L1 can't go any further, therefore I'm done with my solution. And I return the inversion count number. Now the reason why this is very time consuming is that our space that we're doing, our space big O, is actually going to be O of 1. We're not creating anything new, so this is O of 1. And the reason for this is no new creations. However, our time complexity, since we're going through the array twice, basically at every point we go through the array. At every point we go through the array. At every point we go through the array minus 1. So basically this is n to the n. We're going through the array n to the n times, because basically we start at location 0 and we have size n array. So 0, and then this is one loop, so loop 1, and then we have another loop, so we have loop 1 and we have loop 2. If I start at 0, it's going to go through n times. I have 1, it's going to go through n times, or n minus 1 times. Actually, I am not speaking the truth here. This is going to go n minus 1 times. So 1, this is going to go n minus 2 times. 2, this is going to go n minus 3 times. All the way up to this is going to go n minus 1 times, and this is just going to go once. Is basically what it's going to do. So this is going n here to n here, so it's n to the n, which is a horrible time complexity. We never want to hit this time complexity because we can easily break our 3-second execution time period. So it's actually a really, really horrible time complexity. Now let's move over to see what it looks like in the code. So I'm going to move over to the code. So we're here at the code, and basically what I need to do is I need to get the length equals a.length. I'm going to need to make up my count, so inf count equals 0. I have to have my starting point. Then I'm going to say basically int I equals 0. I is less than length minus 1. And I'm just going to increment I. I'm going to create an internal for loop and say int j equals I plus 1. I always want to be 1 above the location that I is at. And j is actually going to go to length. And j is going to be incremented again by 1. And all I'm going to do is say if a of I is greater than a of j, in the count gets incremented. And then I return the inv of count, the inverse count. So basically every single time I have an I will go through the array. Basically j times, j will be roughly n minus I. Or it'll be, n minus I plus 1 is what it's going to be. If I run through my sample tests, I should pass every single sample test. I pass every single one. It's 54 sample tests. And then we have 107 tests in total, which means we have 53 more tests to do in a 3-second time period. Well, our guaranteed constraints is that our A size is going to be equal to 1, or it's going to be equal to, I think that's 10,000, maybe it's 100,000. Yeah, I think that's 100,000. And once we start getting to 100,000, if I open up my calculator and bring my calculator over, so 100,000 to 100,000, it's an invalid input. Well, I guess I don't know how to use my calculator. But it's going to be very, very time consuming. So if I submit, I assume I will crash my execution time limit because I take too much time to execute. Yeah, I get to 106 tests, but I have passed every single test so far. So I know my execution works. However, I'm taking too long to complete it. So this is one solution, and next week I will give you the other solution that should pass this time execution. I'll see you guys next time. Thank you very much.